Tips on how to approach Euclidean geometry questions part 5. Okay, this is the question. So you can read the question. Okay, you are given this diagram 10.1 and 10.1.1. Okay, you have to prove that the line MC is a tangent to the circle at C. Okay, you have to prove that this line MC is a tangent to this circle at the point C. Okay, 5 marks. So to prove that this line MC is a tangent, you can use the chord DC and the line MC. So you are going to prove that this angle is equal to the angle in the alternate segments. Okay, from the chord DC, you have this angle in the alternate segment. Okay, so if the two angles are equal, then MC is a tangent to the circle at C, or you can use the chord AC and the line MC. So if this angle is equal to the angle in the alternate segments, okay, from the chord AC, you have this angle in the alternate segment. So if the two angles are equal, then the line MC is a tangent to the circle at C. Okay, so let's start using the chord DC. Okay, we are going to use the chord DC and the line MC. Let's see if the two angles are equal. If the two angles are equal, then the line MC is a tangent. So we need angle A1, and then we are going to find the angle C2 and see if the two angles are equal. Can you see angle A1 and angle A2 are equal because these two angles are subtended by equal chords. Chord DC and chord CB are equal. You can see you are given DC is equal to CB. So these two chords are subtending equal angles. Okay, the angle A1 is equal to the angle A2. So we can find the angle A2 easily. From there, we know what the angle A1 is. So let's find the angle A2 because we have enough information. We can find A2. So angle A2 is equal to, this is a triangle. Okay, angle A2 is equal to 180 minus 90 degrees minus x. Okay, this is equal to 90 minus x. The reason is sum of angles in triangle ACB. ACB. So angle A1 is equal to angle A2. So angle A1 is equal to 90 degrees minus x. The reason is equal chords subtend equal angles. Okay, always write the reason. Okay, DC is equal to CB. So these chords subtend equal angles. Okay, now we have A1. Let's find the angle C2 and see if the two angles are equal. So to find C2, we don't have enough information. We only have this angle in this triangle. This angle is 90 degrees. We can find the angle D2 because this is a cyclic quadrilateral. Okay, you have 4 corners on the circumference. So remember, this exterior angle is equal to the interior opposite angle. So the angle D2 is equal to x. The angle D2 is equal to x. The reason is exterior angle of a cyclic quadrilateral. Now we have the angle D2. Now we can find the angle C2. So the angle C2 is equal to, you can use this triangle. You have 180 minus 90, okay, minus x, okay, D2 is equal to x minus x. Now you have, this is equal to 90 minus x. The reason is sum of interior angles in triangle DCM. DCM. Now you can see the angle C2 is equal to the angle A1. Okay, this is angle A1 and this is angle C2. So you are going to say, therefore, angle C2 is equal to the angle A1. Therefore, MC is a tangent to the circle at C. The reason, you are going to say converse TIMECODE theorem. Okay, why converse? Converse means the reverse. Please check lesson 24 of 25 to learn about converse. Okay, the other way to solve this question is to use the chord AC and the line MC. So you have to prove that this angle is equal to this angle. Okay, the angle in the alternate segment. Okay, from the chord AC, you have this angle in the alternate segment. So if the two angles are equal, then this line is a tangent to this circle at C. Okay, so let's use another method to answer this question. So we need this angle. We have this angle. This angle is x. We need this angle. Okay, we can use this triangle AMC. Okay, we need angle A1 so that we have enough information to find this angle. So to find A1, we can use this triangle first to find angle A2, because angle A2 is equal to angle A1. These two angles are subtended by equal chords. Okay, DC is equal to CB. So angle A2 is equal to, using this triangle, you have 180 minus 90 minus x. This is equal to 90 minus x. The reason is sum of angles in triangle ACB. Okay, angle A1 is equal to angle A2. So angle A1 is equal to 90 minus x. The reason is equal chords subtend equal angles. We can find this angle, which is the angle MCA. This angle MCA. This angle. We can find this angle using this triangle. Okay, so this angle is equal to 180 minus angle A1. This is angle A1, okay, minus angle A1, okay, angle A1, minus 90, okay, minus 90. This is equal to, you are going to have x. So the reason will be sum of angles in triangle ACM. Using this triangle, you have the angle MCA, this angle, MCA, this angle. So you are going to say, therefore, angle MCA is equal to the angle B. Therefore, the line MC is a tangent to the circle at C. The reason is converse TIMECODES theorem. Okay? Please check lesson 16 of 25 to learn about the TIMECODES theorem, and lesson 24 of 25 to learn about converse. Okay? So let's move on. We're still on question 10.1. Now we are going to answer question 10.1.2. Okay, 10.1, 10.1.2. So prove that the triangle ACB is similar to triangle CMD. So we are going to work So we are going to work in these two triangles. Okay, triangle ACB, ACB, and triangle CMD, CMD. Okay, we are going to work in these two triangles. So to prove that the two triangles are similar, you have to show that the three angles in one triangle are equal to the three angles in another triangle. Okay, so we are going to work in triangle ACB and triangle CMD. Okay, to prove that the two triangles are similar, you have to first show that the three angles in one triangle are equal to the three angles in another triangle. So you can see this angle is equal to this angle. So angle DMC, this angle is equal to the angle ACB, this angle ACB. They are both equal to 90 degrees. Okay, so the reason is you are given that. Okay, you are given that. Now let's show another pair of angles. So you can see you have this angle D2 is an exterior angle of this cyclic quadrilateral. Okay, you have a cyclic quadrilateral. This exterior angle of the cyclic quadrilateral is equal to the interior opposite angle. Okay, angle B. Okay, so angle D2 is equal to the angle B. Okay, remember from question 10.1.1. Okay, so angle D2 is equal to the angle B. Okay, so you have angle D2 is equal to the angle B. So they are both equal to x. Okay, this is x and this is x. Okay, the two angles are equal. So the reason is exterior angle of a cyclic quadrilateral. Now you have proved that two angles in one triangle are equal to two angles in another triangle. Now automatically the third angle in one triangle is equal to the third angle in another triangle automatically. So we have used, let me show you. We have used this angle and this angle, and we have used this angle and this angle. Now you have this angle and this angle. Automatically the two angles are equal. So angle C2 is equal to angle A2. The reason is you are going to write sum of angles in a triangle. Okay, now you can say, therefore triangle ACB is similar to triangle CMD using angle, angle, angle. Or you can write your reason like this: angle, angle, angle. And always respect the order. You can see you have to respect the order. Let me show you. The angle at A is equal to the angle at C. Okay, first letter, first letter. Okay, the angle at A is equal to the angle at C, and the angle at C in this triangle is equal to the angle at M in this triangle. Okay, second letter, second letter. Okay, you can see the angle at C is equal to the angle at M. Okay, and the angle at B is equal to the angle at D. Okay, angle at B is equal to the angle at D. Always respect the order. So you have, this is from one triangle, and this is from another triangle. I want you to see that. Okay, so from this triangle you have A, C, B, this triangle, and from this triangle you have CMD, CMD. Okay, this is from one triangle. You can see you have C2, okay, and D2, okay, and angle DMC, DMC from one triangle, and this is from another triangle. You have angle ACB, this angle, angle B, this angle, angle A2, this angle. Okay, now question 10.2. okay, question 10.2. Hence or otherwise prove that 10.2.1, 10.2.1 prove that cm squared over dc squared is equal to am over ab. 6 marks. So are we going to use this? Because we need cm. You have cm. We need dc. We have dc. You need am. We don't have am. You need ab. You have ab. So we don't have am. So we don't have am. Okay, let me do this. We have to check what we need. Okay, so that you can see in which triangles we have to work. Okay, so we need cm. Okay, we need cm. This is cm, and we need dc. This is dc, and we need am. This is am. let me show you. You have AM. We need AB. You have AB. Okay, so we have to work in two triangles first. Okay, in this triangle and this triangle, and then after that we are going to work in two triangles again, this triangle and this triangle. So for now we need to work in a triangle CMD and triangle ACB. Okay, so let me do this. Since we have this side AB, we need to work in this triangle and in this triangle. Okay, so we need to work in these two triangles, triangle CMD and triangle ACB. You can see from the previous question, this is proven. This triangle, okay, this triangle CMD is similar to triangle ACB. This is proven. We can use this to create the proportionality equation. Okay, so using triangle ACB and triangle CMD, we have AC over CM is equal to AB over CD equal to CB over MD. Okay, so let me show you the way to do it. You have first and second letter in this triangle over first and second letter in another triangle. Okay, AC over CM equal to, now you have first and third letter in this triangle over first and third letter in another triangle. Okay, AB over CD. Okay, equal to, now you have second and third letter in this triangle over second and third letter in another triangle. Okay, CB over MD. Okay, so you have your proportionality equation. So the reason why you can write the proportionality equation is you have similar triangles. Okay, this triangle is similar to this triangle. Now, can you see? You can have DC squared. You have DC or CD. Okay, DC or CD is the same. So you need DC squared. If you do cross multiplication with CB, you have CB is equal to DC. So you have AB over DC or CD, okay, equal to, instead of CB, you write DC over MD. So why do you substitute DC in the place of CB? Because DC is equal to CB. Now you can do cross multiplication. Okay, so DC times DC, you have DC squared equal to AB times MD. now you need cm squared. Okay, so now we are going to work in this triangle and this triangle. Let me show you. In this triangle, and this triangle, okay, this triangle and this triangle. So in triangle AMC, okay, AMC and triangle CMD, we have to first prove that triangles in one triangle are equal to triangles in another triangle. So if we have that, then we know the two triangles are similar. We can now write the proportionality equation. So you have this angle in this triangle and this angle in this triangle. Okay, so you have angle M is equal to angle M. Okay, angle M is in this triangle and angle M is in this triangle. So the reason is common angle. Okay, common angle. You have this angle in this triangle and this angle in this triangle. Okay, and angle C2 is equal to angle A1. The reason is TIMECODES theorem. Remember from the previous question 10.1.1, from this question, angle C2 is equal to angle A1 because of TIMECODES theorem. Okay, now you have two angles in one triangle are equal to two angles in another triangle. Automatically, the third angle in one triangle is equal to the third angle in another triangle. Okay, so we have used this in this triangle and in this triangle, and we have used C2 in this triangle and A1 in this triangle, in the big triangle. Now you are left with this angle in this triangle and this angle in the big triangle, So automatically the two angles are equal. Okay, angle D2 is equal to the angle MCA, this angle MCA, this angle. The reason is you are going to say sum of angles in a triangle. Okay, automatically. Okay, so you have this, let me see, MCD from one triangle, and you have MA and C. Okay, angle C from another triangle. Okay, so these two triangles are similar because you have three angles in one triangle equal to three angles in another triangle. Okay, so therefore triangle AMC is similar to triangle CMD. Always respect the order so that you can write the proportionality equation correctly. So you can see, let me show you. You have to respect the order. So angle at A is equal to angle at C in another triangle. You can see angle at A is equal to angle at C, and angle at M is equal to angle at M. Okay, you have M and M, and angle at C is equal to angle at D. Okay, angle at C is equal to angle at D. Okay, always respect the order so that you can write the proportionality equation correctly. Now you can write the proportionality equation because you have respected the order. Okay, so why is this triangle similar to this triangle? Because of property angle, angle, angle. The similarity property angle, angle, angle. So let's write the proportionality equation. So writing the proportionality equation, you have first and second letter in this triangle over first and second letter in another triangle. So AM over CM, and you have first and third letter in this triangle over first and third letter in another triangle. So this is equal to AC over CD equal to, now you have second and third in one triangle over second and third in another triangle. So you have MC over MD. Okay, so now you need CM squared. Okay, you have CM there and CM there. Okay, CM times CM. Always write the reason why you can write the proportionality equation, because the two triangles are similar. This is why you can write the proportionality equation. Okay, you have similar triangles. For that reason, you can write the proportionality equation. Okay, so you are going to need this and this. You cross multiply. So CM times CM, you have CM squared equal to AM times MD. Okay, using this and this, you cross multiply. So now you have CM squared and DC squared. So CM squared over DC squared is equal to CM squared is equal to this over DC squared. DC squared is equal to this. Okay, can you see? You can cancel MD and MD. So you are going to have this is equal to AM over AB. You have proved. Okay, so let's move on to question 10.2.2. Okay, question 10.2.2. Now question 10.2.2. Okay, we have to prove that AM over AB equals sin x squared. Okay, 2 marks. So question 10.2, now 10.2.2. So we need x. You have to know where you have x, okay? This is x, and remember, this angle is also x, okay? Remember from the previous question. And this angle is x as well, okay? Remember from the previous question. So, using this triangle, okay? In triangle DMC, in this triangle, okay? You have angle x in this triangle DMC. So, this is a right triangle. You have a right angle. You can use trig ratio, okay? Sin x, okay? Sin of this angle, which is x, is equal to opposite, okay? Opposite, you have opposite, which is cm or mc. So, sin x or sin x, this angle is x. This is equal to opposite over hypotenuse. This is opposite, cm, over hypotenuse. The hypotenuse is dc, okay? This is the hypotenuse, the side opposite the right angle, the longest side in a right triangle, okay? Now, you need sin x squared. If you square on this side, you are going to have this is equal to cm squared over dc squared. You square both sides because you need sin x squared. Now, can you see cm squared over dc squared is equal to am over ab. So, you have am over ab on this side because of this. This is equal to, you have this, okay? We have proved. Or you can use this triangle ABC, this triangle, because you have angle x and this is a right triangle. So you can use trig ratio. So using this triangle, in triangle ABC, sin x is equal to opposite, okay? Opposite over hypotenuse. So you have AC, which is the opposite, okay? Opposite AC over hypotenuse, the side opposite the right angle, okay? This side, the side opposite the right angle is always the hypotenuse. This is the longest side in a right triangle. So, sin x is equal to opposite of angle x, AC, over hypotenuse, AB. We need to have this. We have AB in the denominator. Okay. Now, you can use this triangle. Using triangle AMC, this triangle. This is a right triangle because you have a right angle. And this angle is x as well. So, sin x is equal to opposite over hypotenuse. Okay, so you have AM over hypotenuse using this triangle. The hypotenuse is AC. Opposite over hypotenuse using angle x. opposite over hypotenuse, okay, using this triangle AM over AC. So now you have this. You can multiply the two so that you have sin x squared, and you are going to cancel AC and AC, okay. AC over AB times AM over AC is equal to sin x times sin x, okay. So now you can cancel AC and AC. Now you are going to have AM over AB equal to sin x squared, okay. You have proved. So you can see, okay, and we are done.